2, so that's root 2 plus, what is this again? Oh, this is root 2. It'd be complicated. Good luck. Okay, guys, this is where it gets important. We're done going over the homework. I know that was a lot of Riemann sums, but we're done going over the homework. I want to teach you about middle and trapezoidal sums before the second period because I have to go next period.
Hell yeah!
All right. Shh. Ms. Barnum will be able to answer your questions.
He's a math genius.
It's true. Well, it'd be a nice battle between she and I. Okay. Middle Riemann sum. So, yeah, you might want to be taking notes on this right now. I know. So you might already know about left and right. We're getting there. Just let's build. Let's build. I'm trying to make some drama. Okay. Left, so you don't have to write this. It's up to you. Left, you have to write stuff eventually. But this, not necessarily. So listen, you already know this. A left and right Riemann sum. Right? The bars, the rectangles in these Riemann sums get their height from the left and right side of the subinterval, respectively. Left. It's left. No. Left side of the subinterval, that's where the function gets the value from. Sorry, right side of the subinterval for the right Riemann sum. Got me?
Yeah.
Okay. So we know this. We're good at this now, supposedly. But that's why we have left and right. So there are other options, though. In fact, we could choose any set of bars we wanted. And we can have them meet at the middle. We can have them meet at a random place on the inside. Yeah.
Why do you have to have effectively at the end?
So this has left and right Riemann sums get the height of their bars from the left and right. So it tells you that like the first thing here matches up with the first thing here, and the second thing here matches up with the second thing. That's what respectively means. How about a politeness lesson for you? That's what respectively means. You see in a lot of physics textbooks, stuff like that. Okay, so a middle Riemann sum, you should write this. A middle Riemann sum uses the function's value in the middle of its interval for the bar's heights. That's another little English lesson for you.
That's annoying.
So you can see that this is wrong. This should say middle and this should say right.
Do you average them?
Do you average them?
Right and left.
We'll get there. Just take a deep breath. I will guide you. This is the middle. Avogadro, like moles.
I'm 6'2".
6.022 times 10 to the 23rd. I took chemistry my senior year in high school. That was 7 years ago. 8 years ago?
Are we supposed to write the bar?
It's up to you what you want to write. But I want to see, I don't want to answer questions that I've already set out. Let's say it that way. So, this is the middle guy. Can you see? Well, actually, I'll highlight the points with little red stars. Okay? So, on the left side, on the left Riemann sums, the left side of the bar touches the graph. On the right Riemann sum, the right side of the bar touches the graph. On the middle Riemann sum, the exact middle value, okay, is where the graph intersects.
Wait.
No, it's not. I mean, it's not any more confusing than the other ones are. It's just about determining which function value to use. Before we use the function's value on the far left side, 0, 0.5, 1, 1.5. Okay. Then we also knew how to do right ones where we use 0.5, 1, 1.5, and 2. And now we're saying we'll use the middle ones, which in this case is 0.25, 0.75, 1.25, and 1.75.
So if it was like from 0 to 2, then you're like right, whatever. So your line would go up to 2. Like the height of the bar.
So let's say this, right? Here's my and I know my subinterval is from 1 to 3, okay? And my graph looks like this, from 1 to 3, okay? If it was a left Riemann sum, I would use this value for the height, right? If it's a right Riemann sum, I would use this value for the height. If it's a middle Riemann sum, I use f of 2 for the height. See what I mean? You'll see it in the example in a second. People are still writing, so I want to give them another few seconds, and then we're going to do an example together, and then you're going to do an example on your own. All right, ready? First example, write this down. A middle Riemann sum for 1/2 x cubed minus 3x squared from 0 to 8 with n equals 4. just to make this super, super confusing, I've chosen a pretty difficult function. They're the same.
Oh.
1/2 x cubed minus 3x squared.
So the value would be 1.
Right, hang on. Take your time. Yes. Yes. Why you got to ruin the surprise for everyone? Did you write this down yet, or are we going to have to wait for you later? Oh, you? Big boss Maishka over here.
Sweet.
I'm not the boss. Last name Antoine.
Right. Let's go, let's go, let's go. What did you say? Huh?
So she's bosses of failures.
Bosses of what?
Failures.
That's good. Okay, folks, let's get started. So, I'm going to draw the graph. I wouldn't expect you to know. Oh, first let's draw the intervals. This you could do yourself, right? The intervals here, we know we're going from 0 to 8 and splitting that up into 4 even spaces, right? So each one's going to be 2 wide. 0 to 2, 2 to 4, 4 to 6, and 6 to 8. Okay? So if you like my little interval notation, you can do that. If you like it, you can do whatever you want. Okay? I wouldn't expect you to just be able to whip out the graph of 1/2 x cubed minus 3x squared on a test, although you certainly should be able to.
Right.
I would find the x-intercepts by setting it equal to 0 and solving, which you need to know how to do. In fact, you did that in derivatives when you had first derivative tests and stuff, right? If I asked you to tell me the behavior of this graph, you could find its x-intercepts, you could find where it was increasing and decreasing, right, using its first derivative. So you could tell me what the graph looked like.
And where the sign, where it curves, like.
Yeah, you could find its concavity. Oh, remember all that stuff? You're going to have to throw that out on the test in a couple months. All right, chill. Here's the graph, okay? And this is just going to be extra confusing because this graph is negative, so it's going to make it a little hard to visualize, okay? But the first bar goes from 0 to 2, right?
Yeah.
So where should the graph and the bar intersect? At 1, halfway between them, right? So this is kind of, you can see at 1, I did an okay job with this one. Here at 1, halfway between 0 to 2, the graph and the bar meet. Does that make sense?
Would you just like draw a point and then draw E?
Yep, you could do that. You could say, all right, I know 1 needs to be my thing. So you go to 1, draw a point there, and then draw lines out to the end of the subinterval. That's a fine way to do it.
Can you just knock out the word?
Yeah, you can just knock out the picture.
Wait, for X or for Y?
For the midpoint,
Yeah.
X. So for example, the next subinterval is 2 to 4. We choose 3. We say, okay, the bar is going to be where, right here is how high the bar is going to be. The function's value at 3. Make sense? Sort of?
So the bar is always going to hit the line in the middle.
That's why it's called the middle Riemann sum. And the bar is always going to hit a line on the left for a left Riemann sum. All right. Okay, what about from 4 to 6? We choose 5, and that's where the bar is going to interact with it, right there. Yeah, I did a pretty bad job on that one. What's that? I'm not an artist. I'll be the first person to say it.
Yeah, you will.
From 6 to 8, we choose 7, so it's right there. So the bar is going to look something like that. Don't stress on the bars, guys. What's up?
So, if they give you the N,
Shh. Yeah, the number of subintervals is n.
then would you take that and then divide that by 2 or something
For what?
to get the middle?
No.
No, sorry, you divide, no, you get how many subintervals there were and then find out like the range and then divide that by 2?
Yeah. So yeah, but that's just a lot of work. Just find halfway between each subinterval.
Oh, wait, is it?
All right. Yeah, certainly. Okay. So let's talk about the area of each one, base times height, just like we did before. Okay? And so you could ignore the graph, you could ignore the intervals, and just start here if you wanted. Okay? What's the width of all of these intervals? 2. We're going from 0 to 8, so they're all 2 wide. Okay? What about, we're using the midpoint now, so we're not going to have f of 0, and we're not going to have f of 2, we're going to have f of 1, which is halfway between 0 and 2.
F of 1.
Yes, very much so. However, for the next one, when we're going from 2 to 4, halfway between that is
3.
Good, yeah, f of 3, and so on. Okay? Now the middle, remember how I was telling you about which ones won't be there or will be there? From 0 to 8, the middle, if we're doing the middle Riemann sum, we won't have 0 or 8. Okay, we're going to start a little bit after 0, we're going to end a little bit before 8. Okay, and now all you have to do is plug this in your calculator. If you put, or use your head. Let's use our heads, huh? Let's see if we got something left in there. All right, shh. We're staying. So we put a 1 in for x. What do you get?
0.5 minus 3.
0.5 minus 3, so that's minus 2.5, and then the times 2 here? No. All right, shh. Yeah, let's do this in your head, experts. Yeah. If you put in 1, you get 0.5 minus 3, right? Because the 1's 1 is 0. So you get 0.5 minus 3 is negative 2.5, and we need 2 times that. 2 times f before, so it's negative 5.
It is?
Yes, get it together, kids. Plug these in your calculator since you're too terrible at arithmetic to do anything with your lives. And you add them all up, and what do you get, Wally?
What?
I thought you said you got this.
Yeah, I forgot the 3x squared.
Oh, that's pretty important. Anybody know what the answer is? Negative 8 is right, good.
So,
Yeah.
so for the answer, should you write like the area for the middle Riemann sum is -8?
Yeah, that's a fine way to do it.
For the answer.
Does it actually give you the area?
It's an approximation. You can see this one's not that good because of how big off it is. That's not the homework.
I'm not going to do trapezoid.
Guys, you should start with number 1.
I'm not going to do trapezoid. I don't have time.
Do number 1 first. Do number 1, let's go. Number 1. Number 1. No, do number 1. We're going to do that together. You guys will hustle off and finish 1. No, I'm going downstairs. Wait for you. Shh, guys, finish that middle one so I can teach you trapezoidal and get out of here. Mr. Van Houten is waiting for me.
Let's see Miss Barmore.
Ms. Barmore is waiting for you.
Oh, okay.
What do you do?
Eight. How many siblings on this graph? What do you think? Wait, you want 8 for?
Oh.
Don't worry about that.
6. 4 to 12, they each 2. Oh, there's 4.
Wait, I'm confused.
Why?
Oh, we skipped 10.
Massive math over here.
The math genius is in the house.
I'm going to take 5 or something. I want to finish trapezoid yet.
I know you guys.
Come on.
See if you can't finish in 1 minute.
Wait, do you plug in the middle number in the equation to find out?
Oh, yes.
Tyler, what you get?
What is it?
Oh, 296. Please tell me. Kaden, 296.